Yeah, can you come again? Yeah. So we are discussing DynamoDB and the possible questions or the doubts we are expecting or looking answers for. Yeah. Okay, Shani. Yeah.
The,
Go ahead.
the basic, the very first question is what is the difference between the Dynamo versus DynamoDB? Okay, the architecture that we are going over is a Dynamo, not the DynamoDB. My understanding about the Dynamo is underneath file system uh, or storage system. DynamoDB is built on top of the a database built on top of it. The other question that we have is that the difference between the Dynamo versus the Cassandra. Cassandra is a wide column based, but what I read is it's a not row based query; it's a column based query. Cassandra is. Um, the other thing, Dynamo is the best for reads or writes. That's the question we had. Um, and we had a question about the how do we maintain the consistency levels. Eventual consistency is a Dynamo. DB is. Um, eventually, and we also had a little bit discussion about whether it's a consistent hashing or leader follower method is both the Dynamo and the Cassandra. And the other question is Cassandra built on top of Dynamo or Dynamo built on top of the Cassandra? So that is also we had a question. I think that's all we discussed yesterday as of my.
Yeah, and I think we were also talking about indexing structure or like keys. Do we need a sorting key or sorry, do we need a partition key or an additional resolution to locate the records and then find the unique record or the exact record? So probably something like partition key and the search key, or right,
Yeah.
or maybe how the records are basically searched in a DB in a particular partition.
Yeah, we were discussing about yeah, what is the key here? How do you come up with a key? The example that we were discussing is the Amazon cart. When you add an entry in the Amazon cart, is a product ID is a key, or a key is a combination of your user ID plus product ID?
Yeah. Okay. And anything um, around, yeah, I think anything around scalability. I think we didn't go there yet. Okay, sounds good. Yeah. So um, so far we don't have answers to any of these, right? After yesterday's discussion, I think just one thing I came across was like in terms of key. So the way we have a partition key in or the clustering key in Cassandra, we also have a partition key in DynamoDB. So probably like what I was talking about, I mentioned about like calculating the hash from the primary key. I think that was wrong. They do have a separate partition key that is being referred in the consistent hashing ring. So that is something that I uh, found out after we discussed. So yeah, so probably we will have a partition key and a separate primary key or some sort of indexing way to find out the record in that particular partition.
I have one very basic question: is a partitioning and sharding is same?
Yeah, right. Like so sharding is basically we do sharding just to improve the like horizontal performance, right? Horizontal scalability, right? Now the partitioning is in fact same thing, right? We add nodes or virtual nodes to be able to like split up the data like in a horizontal scale, horizontally to make it horizontally scalable, right? So let's consider this thing in the consistent hashing ring. If one of the nodes is unhealthy or if the heartbeats are inconsistent, then probably we will add more node, and then we'll probably create more partitions, right?
But
So
actually, they're saying different. Both are different, but maybe we have to read a little bit more. Yeah, but ChatGPT says both are different. Okay, I
Okay.
haven't read it. Uh,
Okay.
Even I heard someone who was telling to me this morning also, sharding is different and partitioning is different. But I don't know what exactly how they are doing. But yeah, we'll read about it. Yeah.
Are you talking about the generic definition or
With
in
respect to the databases, right? With respect to the database, when we use a term partitioning means what it is doing. When we use the term sharding means what it is going to do.
so partition
Even
is basically when you uh, partition your database, okay, into the same cluster, you can say. And sharding is basically when you distribute it over multiple clusters or nodes.
so if I understand correctly, what you're saying, the partition is you divide a big table into the multiple smaller tables and store
Yes.
it in a single node. And those smaller tables, when you push it to the other node, that's a sharding. Is it what
Yeah,
you?
like a single table is distributed over multiple server or nodes.
Okay. Yeah. I think yeah, kind of on the same page. Yeah. But yeah, yeah, that's good point. Yeah. Thanks, Teja, right? Teja? Okay.
Yeah, I don't know more points about it, but like this is last time I read about it, and I feel that this is one of the
Yeah, yes, I right, Srinivas. Like looks like, as per my understanding, it is a same exist on the same system only. A partition exists on the same system, but I think
But yeah, we will discuss right now. So I mean, I don't have clear understanding, but anybody has it, or we will read it and we will discuss. But that's an open question from my end too. Yeah.
Yeah. Let's come back to this maybe in next session. Let's read it in like maybe after the session, and then so that we can have a healthy discussion there. Okay. Yeah. So just a quick revision. So we covered the so basically from functional requirement point of view, the DynamoDB client, the Dynamo client will have a get and put function. With get, it needs to pass a key, and the context contains the encoded metadata of the object that is meaningless to the caller. So basically they have an additional structure. They are calling it context. uh, and when we pass input, we actually also pass the context, and it is basically returned with the get operation, and then this context will be received from the get operation, and then it will be sent back through the put operation. So I think so far we don't have uh, the answer to what actually the context is referring to, whether that will help us to search the record or not. Yeah, so that's where we discussed and stopped yesterday. Let's start from this. I think we also discussed about the uh, MD5 hashing algorithm for the key, which creates a 128-bit identifier, which is used to determine the storage nodes that are responsible for serving the key, or the the host. Yeah. Let's continue. Does anyone want to?
Sagar, sorry for that. Actually, yesterday I could not join. Now, what is the context here?
Yep, I think we are yet to discover that. I just wanted to highlight that um, there is some context that they're passing for every single put, but we are yet to have the answer, like what exactly the
Oh,
context is
okay,
helping.
thanks.
Okay. Does anyone want to read? Let's take turns, like so that
Robin
everyone
or
can. Yeah, everyone should participate. Yeah, feel
Sagar,
free to.
if not, make it round robin. I mean, if no
Yes.
volunteers, make it round robin.
it,
I can read. Okay,
Sure.
for some time.
Yeah, sounds good. So let's take turns in 15 minutes, like we keep rotating so that everyone will be able to participate. Yeah,
Yes, sir.
go ahead.
1 minute. Yeah. So from where I have to read, like introduction to Dynamo architecture, right? Oh, high level design. Okay. So in high level architecture, we have a Dynamo architecture. So first is a data distribution. Second is data replication and consistency. Third is handling temporary failures. And fourth is inter-node communication and failure detection, high availability, and conflict resolution and handling permanent failure. So at a high level, Dynamo is distributed as table that is replicated across the cluster for high availability and fault tolerance. So, so introduction that Dynamo's architecture. Can we go down? So Dynamo architecture can be summarized as follows: data data distribution. First part. In data distribution, we had Dynamo uses consistent hashing to distribute its data among nodes. Consistent hashing also makes it easy to add or remove nodes from a Dynamo cluster. Yeah, so okay, so same things, right? Dynamo cluster is a multiple. Yeah, cluster is a multiple of nodes, right? Like a Kubernetes. Okay. So data replication and consistency. Data is replicated optimistically. Dynamo provides eventual consistency. What is eventual means? What eventual consistency? Are anybody aware? What is
That
eventual?
means eventually you need to be consistent. There's no need for you to be consistent right away. That's what it means.
Oh,
At
not
some
right.
point, you need to be consistent, but you don't have to be consistent all the time or right away.
Oh, okay, all the time. Okay. That's fine. So handling temporary failures. To handle temporary failures, Dynamo replicates data to sloppy quorum of other nodes in the system instead of a strict majority quorum.
Yeah, so I think sloppy quorum is the same concept from Cassandra.
Okay.
So like with the sloppy quorum, it doesn't require for all replicas to respond. Even if few of the replicas respond, it will serve the read request. In majority strict quorum, every each one of the replica needs to respond. So
No,
Yeah, they explained it in the next following sections very well. This one, yeah.
okay, sir. So you are saying sloppy quorum, so any or it is not mandatory to respond for all the replica, right?
yeah,
Okay. Inter-node communication and failure detection. Dynamo node uses gossip protocols to keep track of cluster state. Okay, yeah, that is a famous. High availability. Dynamo makes the system always writable by using hinted head off. Conflict resolution and handling permanent failure. Since there are no right time guaranteed that node agrees on the on values, Dynamo resolves potential conflict using other mechanisms. Use vector clocks to keep off value history and reconcile divergent histories at return. Second is in the background, Dynamo uses an anti-entropy mechanism like Merkle trees to handle permanent failure. Merkle tree is the first time I heard.
Yeah, we'll discuss a little bit more about Merkle tree. I think that is the one of the very advanced topic.
Hmm.
When that's basic understanding is it's like intra region or intra zone replication, right?
Mhm.
how it is the anti-entropy mechanism. Yeah, that's what they do. Yeah.
Okay.
Yeah, and I think we should also discuss once we complete DynamoDB, sorry, Dynamo architecture, the right time guarantee. I think this is something which makes the write scalable, and the databases which use it are also like are basically scalable for write operations. Like so, let's make a note about write time guarantee, and discuss about it later.
Okay. Yeah. Can we go down? Can we go down? No,
Any,
that I have already read. Yeah.
okay.
Yeah. Data partitioning. Yeah. This is interesting. So data partitioning
So
topics.
one,
That
one,
there.
one question, like one question before how many of us little confident on the consistent hashing? Any?
No, no, I am not confident. I'm not
Okay,
aware of the other.
okay, okay. Yeah, that's fine. So yeah, from now on, like so, then Sagar will discuss dive deep into the consistent hashing part, right?
Yeah, so what we can do is tomorrow when the session start, for first 5-10 minutes we'll go through consistent hashing as a side topic. Just for 5-10 minutes we can limit that, and then we can go about rest of the discussion, continue that, so that everyone so that with the whatever the consistent hashing thing we have learned, we should be able to appropriately apply it in this one.
I think this section is consistent hashing. That's why I'm asking. Data
Yeah. Yeah.
partitioning comes from the consistent hashing. That's why I'm asking it.
Oh,
No,
okay,
no, that's.
okay, my bad, okay.
Yeah, this is whole consistent hashing, right? How you
Hmm.
partition it.
Okay,
Yeah.
perfect. Then I think that's not required. Yeah, but what I'm thinking is like for any of the specific things, we can just have a side discussion about that 5-10 minutes earlier or later.
Yeah.
Yeah, that's what. So here we will discuss what is data partitioning. The act of distributing data across set of node, which calls data partitioning. Yeah. So there are two challenges when we try to distribute data. Yeah. So that's why. So when they are saying data across set of the nodes, right? So that nodes must be the part of the cluster, right? Correct.
True.
True, but in sharding, it looks like it is not mandatory. It will be the part of the cluster, as per my understanding.
That's what man. Let's see. Okay, maybe they're talking about the sharding. Usually, that's how the sharding is. Sharding is like same node, the same node. It has to be in different zone or the region, right? I think that's what the sharding comes into picture, I guess.
So,
But I don't know about the consistent hashing model, how it is. Okay.
okay. So how do we know on which node a particular piece of data will be stored? So when we add or remove nodes, how do we know what data will be moved from existing node to the new nodes? Furthermore, how can we minimize the data movement when node joins or leaves? A naive approach will be to use a suitable hash function that maps the data key to the number. Then find the server by applying modulo on this number and total number of server. For example, a naive approach. So key is Cassandra, hash key is 7, hash key that is 17. Okay, 17 mod total server is equal to. So it is okay. It is a okay, 17 by total server. Oh, that is a has key, right? Whatever the BI it looks like they have done kind of hashing concept, right? Modulo operation. Okay, can we go down? Yeah. So this scheme described in the above diagram solves the problem of finding a server for storing and retrieving the data. But when we add or remove a server, we have to remap all the keys and move the data based on the new server count, which will be complete mess. So Dynamo uses consistent hashing to solve this problem. Okay, the consistent hashing algorithm helps Dynamo map rows to physical nodes and also ensures that only a small set of keys move when server are added or removed. No consistent hashing there. Okay. So up to here we are fine, right? Or we want to discuss anything?
Yeah, does anyone has any doubt so far? Maybe let's so the things we have covered is like the vector clocks, which helps to have the history and the divergence of histories. um, um, and then this is in terms of updating any record basically. And in terms of Merkle tree, again the anti-entropy mechanism to repair any of the rows where we found checksum mismatches, or any kind of repair that is required. And I think what they're talking about is distributing the data across nodes. So the questions they're asking is like how to particularly locate where the record should be stored. And second is like the load balancing, like in case if any node dies or is replaced, how we would move the data or the copies across multiple nodes, or across the nodes, older or newer. So that's why they're coming up with consistent hashing to to answer both of these two questions. So they are saying that consistent hashing helps to map the rows to physical nodes, and whenever any node leaves or joins, uh, with the help of construction, only few records need to move, or only few keys. In fact, my bad, not the records. Only few keys needs to move across servers.
Mhm.
So yeah, Sagar. So could you explain this one? So when it says like consistent hashing algorithm helps Dynamo map rows to physical nodes. So does that mean that a single node in that cluster might not have the uh, complete data in a way like will it be um, so partition data so that if it is partition data, if all the nodes in a cluster uh, doesn't have the complete data, then we assign a new or basically a follow-up node in that consistent hashing algorithm. If we find another node and we assign that into the as the next node. Okay, that part I'm not very clear.
Yeah. To anyone wants to take up this question?
Actually, it is a bit confusing. What exactly the question?
Okay, so the question is, first of all, or probably it might be answered when we look into the consistent hash algorithm,
Hmm?
which is explained below. So I can park my question later on.
No, no, no. We'll just discuss. It's okay. Yeah, no
Okay,
problem.
so it's just like the statement. I think I didn't understand well. So if you go to that statement, if you just scroll down a bit. Yeah, so this one, the last piece says uh, so Dynamo maps rows to physical nodes, um, and also ensures only a small set of keys move when the servers are added or removed. So let's say a new server is added at that time. Uh, so definitely the all the data. So let's say these are the servers which are in a which are like following a consistent hash algorithm. we add a new server, let's say server 6. So the server 6 has to first of all be has to be updated to have all the records which is available at on in server 5. Is that true, or
Okay, you are very close. Okay, so it is not 100% true, but again not 100% false. So I mean, in the consistent hashing is how when you add a new node, right? Some keys has to be copied over to the new node. It is not
yeah,
exactly from the server 5 or previous node. Okay, how we distribute the nodes, right? Again, based on some hash ranges, that
yeah,
those range we have to be mapped to the new server.
yeah.
I guess
So
it is not exactly the previous node or next node copy.
yeah,
I
correct.
think so. Yeah.
Yeah, correct. So let's assume that this is the in the consistent hash approach. This is the hash function, which is hash of key, which is, let's assume that's a modulo, and we bring in a new server which is 6. So what that means is few of the keys will now map to the server 6, and that's the assigned location for the data with the keys which maps to 6 will be stored. So that means the new server 6 will have only a few keys which are now distinct from all the servers in all the previous servers.
No, they don't have to be distinct. Look at it this way, and I think that could help you look put this in perspective. Consider we have 25 keys altogether,
Okay.
or a key space of 25. Right now we have 5 servers. Okay, so if our hash function is modulo,
Yeah.
then whenever any key is being presented, we'll do modulo 5, and each server will host 5 keys.
Yeah.
Are you following so far?
Yeah. Yeah. Yep.
Since we have
Definitely.
25 keys.
Mhm.
Now let's say if we add a sixth server in our current cluster with
Yeah.
25 keys, if we have add a sixth cluster, then the whole ring or the whole data distribution would change, right? Because
Yeah.
our modulus 6 should, let's say if you pass on 12, earlier the modulus 6 was yielding 3, now it should yield 2, right?
Yes.
So when you add a sixth server, there is a need to move certain keys. Okay, so what they are saying is, like with the help of consistent hashing, only certain record needs to be added. So let's say if you add a new server between first and second server, okay, if you add a like server, 25 modulo 6 would be like, in total we just need 4 server, but right now we have 6 servers,
Mhm.
right? So the data will be distributed across all of them. So it should be added in such a way so that there should be less movement of data.
Yeah. Yep.
Because if you
That's
just
the whole
add
idea
a
of
server
consistent
between
hashing.
1 and 2, then all the keys on 2 would be moved, and 3 would be moved, or somehow like we need a bigger shuffle reshuffle to adjust the data.
Mhm.
So just to avoid that,
Yeah, it's a very
algorithm
good.
helps us to minimize the key movement, in a way like that could help scale faster, or be able to add and remove nodes at larger number of times.
Yeah, I think I get it. I'll probably read bit more on this, but just a very basic question, like in this cluster of 5 servers, at any given point in time, none of the nodes in the cluster will have the complete data. Is that statement correct?
No, it has to be there. The
Yeah.
data has to be there.
No,
If
no,
the
no,
data
no,
is
no.
not there,
My
means
question
the
is
node is
like,
gone.
so none of the nodes in the server will have the complete data in a way, like.
So
Mm,
yeah, to maybe to answer your question, these are not replicas. Okay, the data on each server is mutually exclusive.
Yes. Okay. Okay. Yeah.
So these are not actually replicas.
Yeah.
When
These are not
what you
replica.
mentioned
Yeah.
is like when the data is exact same copy, then
Mhm.
that would be referred to as a
As a
replica and not a
Yes,
partition.
correct. Yeah, yeah.
So
Okay, I
each
got
node
it.
has it is not about node level replication. It is about key level replication will be there.
Right.
I mean, like some sort of keys will be moved, replica in the same node. I mean, in the same ring, there will be a replica. That's it.
Yeah. So in a way, like the keys are distributed amongst these nodes in the cluster.
That's right.
Yeah, and again, adding plus one to what Srini mentioned is basically, let's say if we have a key number 1234, which are hosted by server one, there is a possibility that key number one could have a copy in server three, and key number two could have a copy in server four, and key number three could have a copy in server five. There is a possibility that the same keys could have copies in other servers too.
Okay. Okay.
Okay.
Yeah, but just 1 minute for my clarification. Like could key being but for data purpose, suppose here data is not replicated, right? So so if server one has partition one, server two has partition two, right? Then so then data wise suppose A to G, suppose we want to store the data. So server will have A to C, and server two will have D to E, and server three can have F to G. Correct? Is it like that?
It
On
is kind of, but we'll read. But it is each server is not only responsible for handling the newer data. It is also responsible for a replication of other node too. Each node is. Each node has a combination of both.
Uh,
so
Then
let's say,
how? No, the little
um,
confused.
we'll maybe we'll when we'll read the subsequent part, that will be clear. So hold on to your doubt. Maybe you can just put your doubt in the chat if you can, but it will be answered for sure.
Okay, sir.
And also this one, Sumit, right? Your first question is very valid question. Okay, at the end of the today or tomorrow, we should be able to answer, right? Because the whole hash algorithm will change when a new server is added, right?
Yeah.
That means key should be mapped. If you add, if you add between like after third node, right? That means three, four, five, six, right? All the nodes keys should be remapped. That
Yeah.
how we are doing. That's a very valid question.
Yeah, but using the consistent hash, we make sure that that reshuffling doesn't happen. And since we form a ring, so we might find the next the neighborhood in a clockwise. We'll be able to find the new key. I think I have to read
Yeah,
further, but
see, that is not that style, because what about the old key that is stored in the node 5, and if you call a get operation, right? Now you see the hash mod 6 now, right? So
hmm,
you may not be, it is referencing a different node now, right?
yeah,
Those keys has to be mapped somewhere else, right?
yeah,
Now,
correct.
or you
So
change your, you have to change your, you have to tweak your hash algorithm, right? So that's what.
yeah, also just a small clarification, it's not that the reshuffle will never happen. What it says is there will be minimum need of the reshuffling of keys, like like only a small set of keys could be reshuffled, like that could be like the optimum way, like the optimal number of keys would be reshuffled. It doesn't say
And
like
I think that's where Merkle tree comes in role, right? To see which is where is the mismatch, and then we make the change.
yeah.
Okay, let us see. So consistent hashing. Oh, they have explained consistent hashing. What Srini you were talking about? Okay. So consistent
So,
hashing
so
represents
one
the.
one second. Sorry.
Yeah, I'm not.
Yeah, I just wanted to add one thing. So I think we all are missing one very important point in this. I think
Hmm.
originally whosoever asked the question, and that is the crust of the this algorithm, consistent hashing. So I think nobody talked about it, and that is about the there is a concept called as virtual nodes.
Mhm.
So server has a each server will be a virtual node. So when you add a new server, it's get equally distributed among all the servers, so that the load is equally distributed among all the servers whenever a new server is added. So what it means, whatever Sagar just mentioned, I think few minutes earlier, that that is the concept of virtual nodes helps to have the minimum impact of the moving of the uh, load among the all the server in the ring. So I think yeah, that is the whole crux how the things are actually balanced and maintained in the ring through those virtual nodes. So I think you can read up about that, the concept of virtual node, and that's the significance of the consistent hashing through only through word. Otherwise there is no point, right? Every time the hash changes, you add a node, hash changes, and it gets redistributed, which just beats the purpose of the consistent hashing, right?
Yeah, so it's there, Aditya, like in the subsequent part. uh, yeah, so maybe yeah, we should be able to cover that going forward in next
Okay.
topic itself.
Okay. So let us see. So, okay. Should I read a starting or should I start?
Yeah, yeah, start reading. Yeah, also one more thing, Sumit, can you post your question in the chat, like, so that
Yeah, sure. I'll do that.
go ahead, Rakesh.
Yeah. So consistent hashing represents the data managed by cluster as a ring. So each node in the ring is assigned a range of data. So Dynamo uses the consistent hashing algorithm to determine what row is stored to what node. So here is an example of consistent hashing ring. So so this has server 1, 2, 3, 4, and here from here, yeah. So that's why we were talking about, right? So data range 1 to 25, data range 26 to 2050, and data range 51 to 75 and 76. So all has a different. That's why I was asking, right? Like A to C and server B will have D to E. In the sense every server having different data, right? And we are not talking about replica here.
We will talk a little bit down the road. Okay, we'll
Okay.
talk about it. Yeah.
So okay. So here, yeah. So every server has different data, and hash range 1 to 100. What is the hash range 1 to 100? Okay. Number of nodes is 4, and number range per node 100 by number range per node 100 by 4. So all data in the range 1 to 25 is stored at server 1 and so on. Okay. Okay, can we go down? Sorry. So with consistent hashing, the ring is divided into a smaller predefined range. So each node is assigned one of these ranges. In Dynamo terminology, the start of the range is called a token. This means that each node will be assigned one token. The range assigned to each node is computed as below. Range start token value and range end next token value minus 1. So here are tokens and data range of 4 nodes described in the above diagram. Okay. So server 1 will have token 1, range start 1, and range end 25. Server 2 token 26, range start 26 to 50, that is a totally unique. Server 3 will have 51, this is 51 to 75, that is also unique. And server 4, 76 token, and 76 to 100, that is also unique. Yeah. Okay, so whenever Dynamo is serving put and get request, the first step it performs is to apply the MD5 hashing algorithm to the key. The output of this hashing algorithm determines within which range the data lies and hence on which node the data will be stored, as we saw above each node. Okay. Okay, can we go down? So here token is kind of the key here. Token, whatever they are explaining.
Yeah, whatever we were referring to key is called as token.
Token, right? Okay. Okay, can we go down? Yeah, another other question I have is like in DynamoDB, just a base, very basic. So DynamoDB internally, they are using some database concept, or this is Amazon Dynamo is totally unique.
What is the question?
I mean, this Dynamo DB concept is unique, or internally they have using some other databases or any algorithm of other databases.
My understanding is they built it. I think this one,
Oh,
DynamoDB, from back.
uniquely.
It's a key value, yeah.
Okay.
Or
Okay,
maybe
thank
the Cassandra is their reference, but I don't know.
you.
But
Okay. So whenever Dynamo is serving put and get request, the first step is to this one I read right. Okay, is to apply MD5 hashing algorithm to the key. The output of this hashing algorithm determines within which range the data lies and hence on which node the data will be stored. As we saw above, each node in the Dynamo is supposed to store data for fixed range. Hence, hence, the hash generated from data key tells us the node where the data will be stored. Here is an example showing how data gets distributed across consistent hashing ring. Yeah, can we go down? Can we increase little bit font? Yeah. So, so key here, key they have taken as a state. So California city is Sacramento zip code. So it has function to the keys. So California is a 79, Sacramento and zip code. Then we are so CA is mapping to 79. Then here what was 75? So server 3.
Yeah, so basically what they are doing here is like the CA is hashed, it gives us 79. WA is hash, it gives us 3. Like all the key, basically whatever the key is there, it's hashed and it gives us some token value. And then this token value is then getting distributed across, like with the, let's say, modulo function is getting distributed across number of nodes we have. So since our key space is 100, 79 will go to the fourth key space, which is assigned to server 4. So any key, any hash value which is yielding between 76 to 100 would be stored at server 4.
Okay. Okay, Alex, do you want to speak something? I think Alex has raised a hand.
Is something that's topic for sure, but hashing state is a really bad choice because when you search, say, give me all the cities in the state of California, you will find all the works to one node. That's really bad. If you have some function that's really tricky, when you ask for typical search criteria like if it's California cities, you will have multiple nodes working on this point of query. But again, this is not the subject here, so I'm going to
is somebody Alex is speaking?
Yeah, Alex is ping. Yeah, that's why I think voice is not audible, right? I thought.
Yeah.
Alex, maybe if you can increase your voice or like volume.
No, now he's muted. Alex, do you want to speak or can we go forward?
No, I'm sorry. Yeah, this microphone will not work
Oh,
anyways. Sorry. Yeah, let's move on.
okay, sir. Yeah, can we go down? Okay. So so the consistent hashing scheme. Yeah. Sagar, can we go up little bit? Just can we go up? Yeah. Now this diagram. Yeah. So so here, so 1 to 26. This is the key, right? Correct. All the things is a key. 1 to 26, 76 to 100. Correct.
Yeah, it's a token range that we were talking about here, right? Like
Yeah.
the
Yeah.
range
Okay.
start and range end. So the token range is this.
So this, yeah. So my question is, so this range we will generate using the consistent hashing only. How this range will be defined? How we will calculate this range?
It's basically consider that, let's say we are we will, when we will be designing the consistent hashing basically system, we will basically allocate, let's say we want to have a capacity of 10,000 records or 100 records.
Mm-hmm.
So then that's our full capacity, and then according to that number of server joining the cluster, the ring, it would keep adjusting this range. But we could have initially like the number of rows, we can plan for that estimation, or it also depends on like how many keys, active keys we are storing at any given moment. Based on that, it will come up with the range.
Oh, okay, okay, okay. So,
So there could be data or the records
mm,
added or removed. Based on that, it will keep adjusting this range.
okay, okay. So, okay, can we go down? Yeah. So the consistent hashing scheme described above works great when a node is added or removed from the ring, as only the next node is affected in this scenario. For example, when a node is removed, the next node becomes responsible for all the keys stored on the outgoing node. However, this scheme can result in non-uniform data and load distribution. Dynamo solved this issue with help of virtual nodes or whatever somebody was saying right here. Virtual nodes. Okay. Okay, can we go down? So virtual nodes, adding and removing. Yeah. So in virtual nodes topic, adding and removing nodes in any distributed system is quite common. So existing nodes can die and may need to be decommissioned. Similarly, any nodes may be added to an existing cluster to meet growing demands. Dynamo efficiently handles this scenario through the use of virtual nodes. Oh, okay. So as we saw above, the basic consistent hashing algorithm assigns a single token to each physical node. Yeah. So this was a static division of ranges that requires calculating tokens based on wait. Okay, as we saw above, the basic consistent hashing algorithm assigns a single token to each physical nodes. This was a static division of ranges that requires calculating tokens based on a given number of nodes. So this scheme made adding or replacing a node an expensive operation. As in this case, we would like to rebalance and distribute the data to all the other nodes, resulting in moving a lot of data. Here are few potential issues associated with manual and fixed division of the ranges. Can we go down? It is a 7 o'clock. Yesterday, Srinivas, we were talking about the API design, right? After 7 o'clock, we will discuss. Should we continue or?
Yeah.
Yeah, before that, anyone has any doubts so far? So we discussed about like the token ranges, the hash algorithm, which they are using to calculate the token value, and then distributing it across the hash ring. And then I think next is, I think we also like it also says that the scheme can result in non-uniform data and load distribution, and somehow they are trying to solve that, uh, so that the data would be evenly distributed, avoid any kind of hard partitioning or uh, uh, unbalanced partitions. Any doubts, anyone? Yeah.
So they are just using consistent hashing, like, so Dynamo using a concept of consistent hashing. So is there any other problem it is trying, is Dynamo trying to solve? Like, I'm just trying to understand the difference of these two.
So like look at consistent hashing as a separate topic, or a separate thing. Consistent hashing is what usually helps, like it's a mechanism that helps us to have to do the data partition in an optimized way. Wherever the partitioning we can wherever the data partitioning comes in, we can choose to go with consistent hashing scheme. So it's different. And then DynamoDB for its data partitioning is using the consistent hashing. So look at it that way. We are yet to get to the point like how the DynamoDB is scalable, or like uh, I think what was your next question?
No, I think this clears up and we'll get more idea.
Actually, we don't talk about Dynamo DB in this paper, I guess, right? It's purely a
Oh, yeah,
Dynamo architecture.
yeah. I'm so yeah. My bad. Yeah, I keep.
Yeah, we don't talk about anything related to database operations here. I think so. It's just a Dynamo. This is right. How the
So,
nodes are organized and data has been storing it, and how writes and reads are happening. I guess.
So this is what Cassandra also do. It uses consistent hashing. Uh,
Yes,
so what's the difference here, like high level?
Cassandra. I mean,
And
Cassandra is actually based on this paper. So this paper was published way before the Cassandra work. Facebook implemented the Cassandra.
got it.
Yeah, and to the Srini, to about your doubts about the Dynamo and DynamoDB, these are the two different systems. It's not the, I mean, fortunately, unfortunately, they use the same name DynamoDB,
yeah.
but DynamoDB is a completely different architecture. It's a leader-based architecture. And this one, what they document in this paper is a leaderless architecture. And I don't know whether this is just a POC they did and whether they develop any real system based on that or not. I
Oh,
don't
is it?
know.
Oh, is it Dynamo DB is a leader follower method? Oh,
Yes, DynamoDB is a
it's
leader-based
completely two
architecture.
different architectures, right?
Yes,
Okay, it's very good to know, Praveen. Thanks. Yeah, we had the same question yesterday. Like, I was thinking DynamoDB built on top of the Dynamo. No, I think Cassandra built on top of a Dynamo. Okay,
yes, Cassandra is built based on this Dynamo paper.
okay, thank you. I think now it's clears many things. Yeah, Teza, I shared one YouTube link. We had the same question yesterday: Cassandra versus DynamoDB. What are the differences? But of course, Cassandra is a wide columnar database, though. But I found one YouTube video and they were explaining about how it works, Cassandra, and how it works DynamoDB.
Got it. Thanks, Sri.
Yeah. Yeah, thank you. Is any questions?
No, but I have one very basic question, like for related to infrastructure. See, DynamoDB, that is a particularly of the AWS services, right? So
Yes.
if so if we use DynamoDB on AWS, in the same thing we can't reuse, right? For the other, for our bare metal server or Google Cloud or Azure. So it will be totally that we can't reuse it. But suppose Cassandra, if we use Cassandra, so we can use even in AWS, even in Google Cloud, even in bare metal server.
I think answer to your question similar to DynamoDB. I think we have an Azure. I mean, not sure what DB Azure similar to the DynamoDB, but I think whatever you're saying, it's correct. It's within that ecosystem.
Yeah, correct. Because if we are using the Dynamo, in the sense we are dependent on the AWS only. Even we can't use on our bare metal server.
Maybe there is
Say,
a
I repeat again, don't say Dynamo, say
yeah
DynamoDB.
DynamoDB, yeah.
There's
yeah.
no public database in public domain Dynamo. And yes, you are right. I mean, that's their cloud service. So if you want to use DynamoDB, you have to use the AWS.
Hmm.
Uh, I believe that Microsoft has a similar type of
Yeah,
product,
Azure has a similar type.
Cosmos, I think.
Yes, similar. Then why people use that services? I'm saying rather than using that service, Cassandra gives the same functionality. We can use a Cassandra and we can use the EC2 machine. We can deploy on EC2. So they will not.
Cassandra as I said, that Cassandra is, you can't compare Cassandra and DynamoDB. As I said, that Cassandra is a different architecture. It's a leaderless architecture,
Hmm.
right? So it does not give you the guarantee that when you write, so eventually your data,
Hmm.
when you will read, so all will read the same data, but eventually. But
Okay.
in leader-based architecture, it's guaranteed you that you can read your own write. So that guarantee they give you that.
So that is
So
the.
depends on your use case.
Hmm.
You can actually go whatever is more suitable to your use case.
Okay. 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 Thank you.
Yeah. I mean, you can argue that why somebody will use DynamoDB or Cassandra, even SQL give you the same thing.
Hmm.
You write and read. That's
Okay.
what you are looking.
Yeah, correct. No, just I was only curious, like that is a dependency, right? If we develop our application using the DynamoDB, so we are dependent on AWS. We can't use our bare metal server if we want to deploy. So that was, I was curious to know.
So, I mean, you mentioned that EC2 server. So where will you host these EC2 in your own data center, or you are planning to use host somewhere in the cloud?
Yeah, so that's why if suppose we don't use DynamoDB, we use other database in place of DynamoDB. So we can use even other cloud like as a EC2, which is nothing but a VM, or we can use our own bare metal server.
But where will you host? So my
Hmm.
question is that whether you are planning to have your own data center for that, where you will keep all your server, or if you are saying that, okay, EC2 in AWS, then whenever you will need to move to the different provider, you will have to migrate your data.
Yeah, correct. Yeah, that sounds funny. Yeah, if we need it, we can migrate to the our own cloud, any other cloud. But if we use DynamoDB, we are totally dependent on the AWS.
The
We
same
can't.
way, you are, even though you are using the DynamoDB,
Hmm.
and in future you plan to move or depart from the AWS and wants to go to either GCP, OCI, or Azure,
Hmm.
um, you can migrate your data. I believe that all these provide some migration.
So they provide
Yeah,
migration. Okay, okay.
I
Then
believe.
they provide that should be good. Okay.
So once you actually start, so you don't change or make these decision or frequently change or migrate to different provider.
Hmm.
Once you decide, you plan to stay with them for long period of time. You don't think that you will stay for 6 months or a year and then you will move to the different provider.
Hmm.
Praveen, is this DynamoDB is suitable best for writes or reads, or we can't say that. Uh,
I mean, you can tweak and you can use for any. I mean, what do you mean by read and
I
write?
mean, like read heavy machine and write heavy machine, right? If mine is a
So,
mine,
so read and write heavy. What is the definition? What is your load?
um, so so suppose like my system is like Instagram system, like that is like it is a little bit read heavy system, that is. Okay, that means like more reads than writes per day. Okay, 100 is to 1 ratio, that is. Right. So in that case, right? Um, so that means like for me, read latency should be less. Faster read should be there for that.
That is one thing, but are you okay with the some eventual consistency? Say if you write right now, you want to read immediately as soon as you get the notification, or you are okay that your reader is okay to read it after some time. So I believe that in all these social system, you are okay with some eventual consistency.
Correct.
So
Yeah.
when you just post something, it's okay that I read before you. You actually, I read. I get the notification that you posted something, and Sagar gets it's after a minute or so, or 2 minutes or 5 minutes. So it does not make any difference, right? So you can go with that. You can tweak your system like how you want to, how many replicas you can have more replicas for the read in that case.
Yeah, but so the basic, see my point here is like, how can I choose a database here, right? So SQL versus NoSQL is fine, but within the NoSQL, right? Uh, because this is a key value pair. DynamoDB is just a key value pair, right? If you take Cassandra, that is also a key value pair, but it's more of column based, right? On what basis I have to choose the database here?
I believe that the DynamoDB also actually provide you that the same similar kind of functionality.
Correct.
Though it says its name as key value, but it's provide you the similar kind of functionality in that.
I think the question is within NoSQL, given your application, how do you choose between DynamoDB and Cassandra?
My answer is same. I mean, depends on your use case, what exactly, I mean, your requirement, your bottleneck in your what problem you want to solve. You can't actually solve all the problems with one database. So you have to prioritize that what is more important.
Could you give an example of like when I would go for like Cassandra or I would go for DynamoDB?
I mean, to be honest, I can solve all the problems with any database. Whether it's a SQL, I don't think so. Even the SQL is a problem.
Yeah. So
Each database has their own problem. When you will go with them, it's not just out of the box. You will get actually all the problems will get solved. For example, I mean, Meta has their database. They have one of the massive amount of IOPS, and they use underneath they use MySQL. They are not using any. They moved away from Cassandra, though they developed it, but they are not using it.
Okay, yeah, thank you. But so, but with respect to the interview point of view, right? If
Mm-hmm.
somebody asks me like, why did you choose a DynamoDB rather than Cassandra, right? Uh, what is the best answer that I should provide here, or any? I mean, it's not an answer, just any thoughts on that.
Yeah, yeah. So you are taking an example for this read write, right?
Hmm.
The, the example you took, that Instagram kind of thing, right, where you have more reads and less write, correct?
Yes, yes.
So you can start actually uh, talking about that underneath storage engine, which actually help you uh,
LSM and B plus,
to
right? That's yeah.
LSM and B tree.
Hmm.
So you can argue